My goodness. All right, can you indicate if you can hear me, please? Can anyone hear me? Okay, you can hear me. All right. So we have a couple of questions to solve today. I really hope we can have enough time to solve all these questions. There are lots of them, all majorly last year's question. We'll be starting with sequences and series, and my desire is for us to solve as many as possible. All right. Please take note of the question so that we can solve together. So this is last year's question, question number 1B, paper type MSA 011. So the question read, please, you will have to, I may not be writing the full question, just the solution on the board. So the question read, the sum of 5 terms of an arithmetic progression is 10. The sum of 5 terms, the sum of 5 terms of an arithmetic progression as an AP is 10. And the sum of their squares, the sum of their squares is 380. So the sum of 5 terms, the sum of 5 terms is 10. And then the sum of their squares that means the squares of this term is 380. So the question said, find its first term and common difference. So you have to find A and D. So this is the question that came out last year, and it carried a total of 5 marks. So let's see how to solve this question very quickly. So you have to make use of your understanding of arithmetic progression in solving this. So you're told that the sum of 5 terms. Now, what is the general term for when you're talking about sum? The sum of n terms of an AP. Well, the sum of n terms is given as n over 2, 2a plus n minus 1 d. So this is the general term when you're dealing with sum. This is the general term. Now, you are then told that the sum of 5 terms, don't forget that was the beginning of the question, the sum of 5 terms. That means in this case, n was 5. And then you were told that the result of those sums were 10. So that means this Sn, rather than this Sn now, you can write Sn as this particular Sn. We're told that it was equals to 10. So I can go on to write 10 equals to, n is 5, that will be 5 over 2. We don't know the A, we don't know the D, but we know the term is 5. That's 5 minus 1 D. So solving this, we have 10 equals to 5 over 2, 2A plus 4D. If we decide to factorize 2 outside, of course, this is something I believe we can all solve. We can go on to factorize 2 outside. So we would have, for this particular case, for the right-hand side, we can have it as this, just this place alone, we can have it as 5 over 2 times 2 into bracket A plus 2D. This is just so that we can cancel these 2 out, because we can see that the denominator has 2. So of course you can go through different routes, you will still get the same answer. So I'm looking at this also, I can see that 10 equals to 5. So let me write that here. So what I have is 10 equals to 5 into brackets a plus 2d. Obviously, you can see also that we can divide both sides by 5, and then this will cancel this. So our final conclusion will be 2 equals to a plus 2d. From here, I can have my d, of course, 2 minus a over 2 will be my d. You can solve that. You move 2 here, you move a here, you'll be having 2 minus a equals to 2d. Divide both sides by 2, you will have 2 minus a over 2 equals to d. All right, so I've gotten an expression for d. So what do I do with this? I've been able to use the first argument, that's the sum of the first 5 terms. This particular argument, I've used this to get my expression for d. So I can go on to use the other arguments now to see what I will get from there. So I was told that the sum of their squares is 380. So don't forget the question said the sum of 5 terms, the sum of 5 terms, the sum of 5 terms of an arithmetic progression is 10. All right. So if we're going to bring that out, we're going to be having, I'm sure you know that if we're going to bring out the 5 terms out, it's okay if we call the first term a, the second term will be a plus d, the third term will be a plus 2d. So let me write that here. So if we're going to talk about these terms, of course, the first term can be a, the next term will be a plus d, the next term will be a plus 2d, the fourth term will be a plus 3d, and the fifth term will be a plus 4d. So this is the 5 terms we're looking at. So when we were told that the sum of the 5 terms of the arithmetic progression is 10, that was what we used to get this. Then we're then told that the sum of their squares, the sum of their squares, the sum of their squares. Of course, these are the terms now. So let's try to act like we want to make the sum of their squares. We wanted to square all this. We'll be having a square, the sum of their squares, the sum of their squares. This is their squares, squaring each of these 10. Yeah, we're then told that the sum of those squares is 380. That will be a plus d square, a plus 2d square, a plus 3d square, a plus 4d square. So you are told that all this is equals to 380. This is what that word problem was saying. So the word problem said the sum of their squares. These are their squares. We're squaring each of the 10. And we're told that when you added all those squares, we got 380. So this is nice. Don't forget we have got an expression for d here. Our d is 2 minus a over 2. I want you to try and walk along because I'm sure you guys are with your jotters, your books and everything. So you can walk along so that you can get the best from this class. Now, you're told that the sum of their squares. So you have your d expression as 2 minus a over 2. I want you now to go on now. While I'll be doing mine, you can do yours also. Wherever you saw d, fix in this value of 2 minus a over 2. That way, we'll be able to produce a value for our a. So everywhere you saw d now, you can put in the expression for 2 minus a over 2 as d in this particular equation. So you can go on doing that while I will be doing mine here, so we can all work together. So wherever I saw d now, I want to start fixing the value of 2 minus a over d over 2. This is 5 marks, and it's quite very simple. You can get all the marks here. So a square plus, I will have a plus 2 minus a over 2. A plus, now d is 2 minus a over 2. 2 minus a over 2. All this square, don't forget, plus a plus. Now, where I saw d now, I'm going to be fixing 2 minus a over 2. And don't forget, there is a square there. Again, this is for 3D. I will have plus a plus 2 minus a over 2. There's still a square there. Then the last one I have plus a plus 2 minus a over 2. And everything still has a square. And all these were told that it's equals to 380. I'm sure you guys are following attentively. All right, so what we then need to do is to go on to resolving each of all these values. So patiently and carefully, we have to find a solution to every of these problems. All right. Now, this is what I'll be doing. I'll be trying to resolve for some of them not exact, so we can maximize our space. So just pay attention now. We are having 2 minus a over 2, and we're having a. If I go on to resolve what is inside here, I will have a plus 2 minus a over 2, right? If you split this up, I will have a plus 2 over 2 minus a over 2. This is, I just brought out whatever we have here. That was what I brought out here. So 2 over 2 minus a over 2. This cancels this. I'm left with a minus a over 2. So looking at this, we can go on to find an LCM there. So we are left with a minus a over 2. So we go on to find the LCM there. We'll be having 2, and that will be 2a minus, are we correct? 2a minus a. And that will be what? A over 2. All right, so if you look at the second side of things, we have a plus 2 into bracket 2 minus a over 2. Now, if you try to resolve this, what you will get is, I want to try and resolve all these inner brackets before we then bring everything together. So we have a plus 2 into bracket 2 minus a over 2. That's what we have here. So let's try and resolve this. Of course, these two, we cancel these two out, so we'll be left with a plus 2 minus a. and then we'll be left with a minus a, 2. So this whole thing here will decompose to the value 2. You can see how we proved that. So when next we're writing this equation, I'll be writing 2 for this particular place. So that's how we're going to solve each and every one of all this. So keep that in mind. So let's try and solve for the third one. The third one we have a plus 3 into bracket 2 minus a over 2. If you decide to find the LCM of this, of course, you can open this up. If you open this up, this will be a plus 6 minus 3a over 2. So if you decide to find the LCM of this will be 2. And then you'll be having 2a plus 6 minus 3a. And what this will give you is 2a minus 3a, that will be a. That will be 6 minus a over 2. Sorry, for this very first one, I'm noticing that we're supposed to still have, this is supposed to be 1. So it's supposed to be a, is what we're supposed to have for this first one is going to be a plus 1 minus a over 2. So our final answer, finding LCM, will be, if you find the LCM, that will be 2a plus 2 minus a. So that will be a plus 2 over 2. That will be a over 2 plus 1. So for the very first one, let's try and catch this up together. For the very first one, this very first place, this one here, this is what we'll be fixing inside, a over 2 plus 1. For the second one, we got the value of 2. For the third one, we got the value of 6 minus a over 2. So let's solve for the fourth one very quickly. Let's solve for the fourth one. That means for this last one. So note all this so that when we are fixing them in, you will not be wondering how do we get them. So for the very first place now, this one, this is what we're going to be fixing there. For this second one, we have gotten the value of 2. For this third one, we have gotten the value of 6 minus a over 2. So for the fourth one, let me solve the fourth one here. And then let's see what we're going to get from there. So for the fourth one, we have, this was what we had there. We had a plus 4 into brackets 2 minus a over 2. So let's see what's going to happen here. Of course, if you decide to solve this, 2 here, we cancel the 2 here. You'll be left with a plus 2 into bracket 2 minus a. This will be a plus 4 minus 2a. This will be 4 minus a. So you can see how we're going to okay. I'm seeing some people talking about being confused. What do you want me to explain again? We started by this particular, what we have here is the terms that we were told that we had 5 terms. So this is term 1, the first one a, next one a plus d, a plus 2d, a plus 3d, a plus 4d. Then we were told, there was an argument we were told that the sum of the squares of this term is 380. So we went on to say, okay, let's try and square all of this. So we squared them, a square plus a plus d square plus a plus 2d square and up till a plus 4d square. So after doing that, we got what we had here. But we had already used the very first argument. We have already used the other previous argument to arrive at d equals to 2 minus a over 2. So what we do next is that we're fixing into each of all these these are our particular equation. We're fixing the value of d as 2 minus a over 2. So wherever we saw d, we fixed this in. So what we're doing at this point is that we're trying to resolve all what is inside this particular bracket. All these brackets, we're trying to resolve it. So I just finished resolving that of this one. Look at what was inside the bracket. A plus 4 into bracket 2 minus a over 2. So I had this. So from my normal algebra, what we had to do was to cut. We can cut this because you can see 2 can go in 4. So 2 go in 4 2 times. So I'm left with a plus 2 into bracket 2 minus a. And then I'm left with a plus 2 times 2, 4. And 2 times a, 2a, minus 2a. A minus 2a is minus a. And then this is 4. So from now on now, I will no longer be writing what we have here. I'll be fixing this particular value there. The same thing goes for every other one. Like for this particular one now, look at 2 here, we cancel 2. I'll be left with a plus 2 minus a. A minus a is 0. So you'll be left with 2. So I'll be writing 2 in this particular place next. And then I did for the rest. I did for this also. When I did for this, I got my value to be 6 minus a over 2. You can go on and solve this yourself. And you will see how it's all very easy. There is no big deal about it. It's very easy. So from now on, I'll be fixing those values in. So I want to go on now to clean all this and then fixing the values there so that we can move on from there. I'm sure you guys are clearer now, right? We have many questions to solve today. I want us to move right. Trying to watch the time. All right, so now I want to fix in all those values I just got. And fixing those values now, I have a square plus, now I'm fixing that value in. The value I got then, if you remember, was a plus 2, a over 2 plus 1, or a plus 2 over 2. So I'll be writing a over 2 plus 1. It's still the same. This was what we got inside this very first place. Don't forget there's still a square there. Then this one, don't forget what I got here was 2. So this is 2, and there's still a square there. Plus, what I got here was, I got 6 minus, what I actually got was 6 minus a over 2. That was what I got at this, which I wrote it here, 6 minus a over 2. Now, but I can go on to solve this because this is 6 over 2 minus a over 2. So I'm not wrong if I write 3 minus a over 2. I'm not wrong to write that. I'm sure you can understand. So that's what I'll be writing. I'll be writing 3 minus a over 2. So, and don't forget there is still a square there also. And then the last one, don't forget we got our value to be 4 minus a. Then there's still a square there. And every of all these things was equals to 380. All right, I'm sure you guys are following. So what's the next thing we're going to do now? We're going to decide to square them. So this is the reason why it would be very nice if you guys understood how to square any expression. But let me just try to teach those of you that are not yet very familiar with squaring expression. When you have any expression, take for instance 2 minus 3x squared. You don't need to start opening all of these things. What you have to do is to just follow this rule. It will always work. What's the rule? The very first term, you will square that one. So in this case now, I will say 2 squared. That's the first thing to do. Then the next thing to do is that you will multiply all of the terms together, this including the power. So what I will do next is I will say 2 times 2 times minus 3x. So what's 2 times 2? That's 4. 4 times minus 3x. That will be minus 12x. I'll just write that here, minus 12x. That's the easy way of doing this. And the last term will be, you will take the second term now. Don't forget, the first one you took the first term raised to power 2. You will now take the second term also raised to power 2. That will be minus 3x all square. That will be minus 3x all square. So this will be 2 square. That will be 4 minus 12x, then plus 9x squared. Because minus 3 square is 9, x squared here. Let me try and solve one more, and just to get you more in shape, in case you have not gotten it. Let's try and solve for 3. Let's solve for 3 minus 2y squared. Let's see how this goes. So as I told you already, the first thing to do you take the first term raised to power 2. That will be 3 squared. The next thing to do is that you would multiply all of them together. That will be 2 times 3 times minus 2y. 2 times 3 is 6 times minus 2. That's minus 12y. I'll just write it as minus 12y. And then the last one is that you will go on to take the second term all squared. That will be minus 2y all squared. Minus 2y all squared. In this case, I'll be having 4 plus 4y squared. So all this will be plus 4y squared. You need to know this fast method because you need to save your time. So that's what I'll be using to square all this, what you have on top here. It doesn't work if the power is more than 2. It only works for 2. So it's for 2 alone. For that person asking the question, it doesn't work for, it only works for when the power is 2. So now, that's what we'll be using to solve all these things. And you will need to flow with us. All right. The very first one is a squared. Now the next one we have, look at it, we have a over, I told you now, just recently now, we will take the first term, we'll square the first term. That will be a over 2 squared. So it's like, if you decided to do a over 2 squared, what's it going to be? Because I want to write the final answer. What's a over 2 squared? A over 2 squared will be equals to, of course, this same thing as writing 1 over 2 times a squared. This same thing as writing 1 over 2 squared times a squared. And 1 over 2 squared will be 1 over 4. So that will be 1 over 4 a squared. So this is a squared over 4. That's simple. So instead of writing, the very first term for this question will be a squared over 4. A squared over 4. Then the second term will be, I told you, multiply all of them together. So multiplying all of them together now, you'll be having 2 times a over 2 times 1. Of course, 2 times 1 is 2 times a over 2. So you are doing 2 times a over 2 times 1. This, we cancel this, you are left with only a. So the answer there is a. You can use the binomial expansion, but I don't know why you would want to use binomial expansion here. So you are left with only a as the second term, a, and then the last term there will be 1 squared. That will be 1. So let's fix this in a bracket. So I've successfully squared that very first term. So first term has been, this very first one has been squared. Of course, 2 raised to power 2 is 4, so that second one also is done quickly. Plus 4, then plus, let's try and do this one. Of course, the very first thing to do here is 3 raised to power 2, that will be 9. That will be 9. Then going on to multiply everything, that will be 2 times 3 times a over 2. So this will be 2 times 3 times minus a over 2. This will be 6 times minus a over 2. 2 cancels. This will be 3. This will be minus 3a. So the second term there will be minus 3a. That will be 9 minus 3a. So this is how you flow easily when you know exactly what you're doing. It's not difficult at all. You just need to understand the procedure. Now the last term there, you'll be having minus a over 2 squared. 3 squared, you have done 3 squared to be 9. You multiply the 3 things together to get minus 3a. Now we're doing the second term square. That will be, of course, the square we cancel the minus. So we're having positive a squared over 4. That will be a squared over 2 squared. So what we have here will be a squared over 4. So we're done with the third term. Oh, sorry, the fourth term. We're going to the last term now. So for the last term, we have 4 squared. That will be 16. Then multiplying all of them together, that will be minus 8a, then plus a squared. That is how we do it. So all of this, don't forget, is equals to 380. I'm sure you guys are following. So it makes so much sense now. You can see how easy this is. So, but you have to just walk carefully and gently. So what you have to do next now is to collect terms that you love. I want to collect all the terms that have a square to one position. So this is what I'm going to do. Everywhere I see a square, I'm going to just group them somewhere. And everywhere I see a, I group them somewhere. Everywhere I see a constant term, I group them somewhere. That makes my work easier, and I can easily do what. So this is a square here. I put a square here. I can see another a square over 4. I bring it also a square over 4. Let me check for a square. I can see a square here. This is another a square over 4. And I can see another a square in that last place. That's a square plus a square. So let me put all of this in just one bracket. They are fine in one bracket. We can keep them there safely, right? So now let's look for where we see a alone. I can see a alone here. I can see a alone there. I can see minus 3a here. Then I can see minus 8a here. Let me put that also in one bracket. They can stay here easily. Then let's look for the constant term. The constant term, I can see 1 here. So we have plus 1. I can see 4 here, plus 4. I can see 9 here, plus 9. I can see 16 here, plus 16. All of this is equals to 380. Making sense, right? That's how easy it is. You can get 15 over 15 in your Maths 01. There's no big deal at all. This is last year's question, so this could have been you last year if you did the program last year, and you'll be meeting a question like this. So simple, so straightforward. All you need to do is to solve confidently. All right, so we are having a nice, we've gotten to a nice position. So you can do your math here. I'm going to do some interesting things. When I have, this is a plus a squared plus a squared will obviously be 2a. But look at this one. I'm going to say this is equals to, it's like I have 2a squared over 4, because I have, this is an a squared over 4, this is an a squared over 4. So I have 2 of it. So easily I will just cancel, this will be a squared over 2. So I'm going to reduce that to a squared over 2. So I'm going to be having a squared plus a squared obviously gives me 2a squared. Then a squared over 4 plus a squared over 4 will give me a squared over 2, as I did there. A squared over 2. Let me put that in this bracket again. So can you solve this one? A minus 3a, that's minus 2a. Minus 2a minus 8a, that's minus 10a. Minus 10a. 1 plus 4, 5. 5 plus 9 is what? That's 14. 14 plus 16, that's 30. Plus 30. Do you see how nice this is? We've been able to bring everything. It's so simple. So see where we have gotten to. So I can go on to find the LCM of this, just in case you need to do that. Find the LCM here. This will be, so here we'll be having 4a squared plus a squared. Of course, we continue with our minus 10a plus 30 equals to 380. So we're left with, this will be 5a squared over 2. So this is 5a squared over 2. I'm sure you are taking good notes. This is very important, equals to 380. So what do we do next? We can decide to solve all this by multiplying through with 2, because we need, we don't like the fraction there, so we can multiply through with 2. And then what do we get when we multiply through with 2? We'll have 5a squared minus this one we turn, if you multiply through with 2, so we can cut the fraction 2 here, but it would affect this. It will also affect this, and it will also, of course, we should have brought this in. Let's decide, let's bring this in. That will be minus 380 equals to 0. And then when we do this, we'll get minus 350. So this will change to minus 350. So if we multiply with 2, we'll be having minus 700. So that's just to save space for workings and the rest. So we can decide to divide everything now with 5. So divide everywhere with 5 over 5 over 5 over 5. And what do we get when we do that? Of course, we will get a squared We get a squared minus 4a minus 140 equals to 0. So can you see how we are able to get to this very nice place? We got here because we went steadily, and yeah, this is, yeah, somebody is talking about treating one question. Yeah, this is 5 marks, and this is how it goes. You have to work carefully. So if you go on to solving this, what do you get as your a value? Of course, if you solve this, you will get your a to be 14, because that will be looking for something that when you multiply together will give you 140, and when you add together will give you minus 4. The two factors there will be minus 14, and you would say, you can say plus 10a and minus 14a minus 140 equals to 0. So this will be a plus 10, and this will be a, of course you have plus 14 rather, a plus 10. Let me just do it in total. So we bring out a here, we have a plus 10, and then minus 14, you will have a plus 10. So we have a equals to 14 or minus 10. Can you complete that and find the value for D quickly and let me know the answer? All right, so when you decide to use your A as 14, if you used A as 14, of course, don't forget our D was what? We got our D to be 2 minus A over 2. So if we are using A as 14, if A equals to 14, our D will be equals to 2 minus 14 over 2. That will be minus 12 over 2. That will be 6. Minus 6 rather. And if we decided to use our A to be 10, then we'll be getting, if A was 10, then our D will be equals to 2 minus, sorry, if A was minus 10, so our D will be 2 minus 10 over 2. That will be 2 plus 10 over 2. That will be 6. So the value for D is 6 and minus 6, depending on what your value for A is. So that is how we solve the question that was given last year. Of course, some questions take a while to get, while some it's much more simpler to get. So we still have more questions to solve. Let me see how you're going to. There's another question, the same last year question on sequences and series. I want to read that out, please. I would like you to take your notes so that we can solve together. So this is for paper type MSB 021. The same sequence and series, but a different question. So the question read, the sum of 3 consecutive terms of a geometric progression is 14. So this time we're dealing with geometric progression. So take in your values. The sum of 3 consecutive terms of a geometric progression is 14. And the product is 64. The product is 64. Find the terms of the geometric progression. This was just 3 marks. Last year, 3 marks. Paper type B. So the sum of three consecutive terms of a geometric progression is 14. Find the terms of the geometric progression. All right, I'm sure this is quite easy for everyone. We can go through two different methods. Maybe I will just solve one for the sake of time. I'll use one method here, but whatever method you use, you will still get your answer. So how do you solve this? Of course, we all know that the two different methods, these are the, of course, someone may decide to say, they said three consecutive terms. Someone may decide to say the three consecutive terms are these terms. That's the first method you can move through. While somebody else will decide to follow that these are the first terms. These are the first three terms. These are the three terms. So this is, of course, they are all correct because the only thing the question said was that there was three consecutive terms. So these three are consecutive and these three are also consecutive. So which one will you prefer us to move through? The left or the right? Let's use majority carrying the vote here. Both of them will get the same answer. Okay, the right. Somebody said the right. Okay. So let's use the right then. So we're told that, oh, okay, we're having a vote left, right. We're having left, right, left, right. Okay. Okay, so the sum of right. Okay, let's just use right. Let's just use right, please. Or we could use left maybe later. So the sum of three consecutive terms. Of course, in case you are forgotten, this is the first term here. This is the second term. You know the ratio. The ratio is what? So this is the first term multiplied by the first ratio, then by the ratio again gives you this. So the common ratio is what makes the difference. Now we're told that the sum of these three terms, that the sum is 64. So if we're told that the sum is, so we're told that the sum is 14. That means we're told that in this case we are using this one now. So we're told that a plus ar plus ar squared equals to 14. And then we also told that their product is 64. That means we are saying a times ar squared equals to 64. All right, very important that you note all this. Let's try and move from this product. A times ar squared is what? This would be a cube, r cube. I'm sure you agree with me because we have a times a is a raised to power 3. R times r squared is r cube. Right? Good. Now, we can also sum this as ar raised to power 3 equals to 64. I'm sure you are still following me. Now, for us to find the values here, we can take the cube root of both sides. The cube root of both sides. Of course, this will cancel this. And then we'll be left with ar equals to, what's the cube root of 64? The cube root of 64 is that number that when you multiply it in three places, you will get 64. If you check through, that number is 4. 4 times 4 times 4 will give you 64. So a half is equals to 4. From here, I can decide to get my a value to be 4 over r. That's by dividing through by r. So let's identify with this, and then let's go on to check the very first equation we had. This was the very first equation we had. That was the sum of them being 14. So let's go on to now fixing our a into this first equation. Let's fix in our a as this there. So that means we'll be having 4 over r plus 4 over r times r, because that's ar, plus 4 over r squared. I'm sure you are following. And equals to 14. So if you follow through with this is 4 over r. This r will cancel this r, you are left with 4. This r will cancel, you'll be left with 4r equals to 14. This is nice, right? Okay, so what do you do next? Let's decide to multiply through with r because we want to try and diffuse this. We don't want this fraction. So let's multiply through with r. So when we do that, what do we get? I'm continuing from this place. So what do we get? We have, of course, that r we cancel the first one, so we'll be left with only 4. But here we'll be left with 4r because we are multiplying through with r. And this one will turn to 4r squared. And this one will turn to 14r. We're multiplying through with r. So let's try and make our, we are seeing like a quadratic expression coming out already. You should be very open to that. This is 4r squared. I can say r, I can say constant value. This looks like a quadratic equation already. So let's try and rearrange well. 4r squared plus 4r. I bring this in, that will be minus 14r plus 4 equals to 0. So if I do this, I'll be having 4r squared minus 10r plus 4 equals to 0. And we can decide to divide through with 2. Dividing through with 2, we have 2r squared minus 5r plus 2 equals to 0. Now we can go on to look for our factors. I believe factorization should work here. So we have 2 times 2, that's 4. So when you multiply, we get 4. And we get 4 and we get minus. What values are those going to be? Multiply, we get 4. What are our factors? So that will be 4, okay? So 2 times 2 is 4, so we'll be having minus 4 minus 1. So that will be 2r squared minus 4r minus r plus 2 equals to 0. Let me make this so that we can use this space well. So we have, bring out 2r now, we'll be left with r minus 2 minus 1 into r minus 2 equals 0. So my 2r minus 1 equals 0, or my r minus 2 equals 0. So my r equals to 1 over 2 or 2. Can you see how easy this is? So I've been able to get my r to be 1 over 2 or 2. Now, this is how you're going to get your final answer. You've gotten your common ratio. Don't forget, the question told you to find the terms. So you want to know the terms. Is it the second term? Is it like, what are the terms? What are the terms? What's your A? We identify this as the term. So what is this? What is this? What is this? That's what we want to know. What is this term? What is this term? What is this term? So if our r was 1 over 2, fix r as 1 over 2 here. What do you get as your A? That will be 4 divided by 1 over 2. If r was 1 over 2, you'll be having your A as 4 divided by 1 over 2. That will be 4 times 2. So if r was 1 over 2, if r equals to 1 over 2, my A will be equals to 8. So, and if my A was 8, that means my term will be 8 as the first one, and 8 times r, that will be 8 times 1 over 2. My next term will be 4. And this one, that will be 8 times 1 over 2 squared, that's 1 over 4. That will be what? 2. So if my common ratio was 1 over 2, my terms will be 8, 4, and 2. Now, but this is the thing. If you decide to use r as 2, That means it's just the reverse that will happen. If you decide to use R as 2, you'll be having your A to be 2, because that will be 4 over 2. If you don't forget, your A is 4 over R. So if R was 2, your first term will be 4 over 2. That will be 2. And then next one will be 4A as 2. That will be 2 times R. So your first term, your A is 2. That will be 2 times, what's your R? 2. The next term will be 4. And then you have 2 squared. That will be 4 times your A, which was 2. That will be 8. So the only thing that will happen whenever, if you decided to use R as 1 over 2 is, or R as 2, is that if it was 1 over 2, your terms would be 8, 4, and 2. If it was 2, your term will be 2, 4, and 8, which is still the same thing. So all you're interested in is to specify what you're doing. So this is how we solve this sequence and series question. Quite very simple. So these are all past questions. We have other questions to solve. I don't know. What do you guys say? I have there's a question on binomial expansion I thought we should solve, and there's still a question on mathematical induction I wanted us to solve. Actually, 2 questions on binomial expansion. Are you guys good to go? Should we keep rocking? Which one will you prefer me to do? Mathematical induction or binomial expansion? Or do both? Which one? All these questions are all here. Okay, somebody said binomial expansion. Okay. Okay, binomial expansion. All right, let me solve some few questions on that. Just 2 questions on that quickly. Two questions on that quickly. So this question, please take it very quickly. You can attempt to solve. He said, find the constant term. Okay, you said it's not simple. This is quite simple, I think. You have to just practice more. So find the constant term in this binomial expansion. Find a constant term. You can keep attempting that while I'll come and solve it. Find a constant term. This is a past question also. You have to find a constant term in this particular binomial expansion. Oh, somebody wants me to solve the mathematical induction question. Of course, we can't exhaust all the question in one night. That's why I wanted us to take more time to study and practice together, because there are too many questions and they are all likely to come out. And this is how you get your grade. If you are able to ace each of all these topics. So we're still on last year's question majorly. So, okay, somebody said we should do the binomial question after. Okay, we can do that. One binomial, one MI. Okay, no problem. All right, don't worry. I'll give you the MI question. So let's solve this one. We have another question. Last year's question on binomial expansion. We can solve that in a different class. Maybe not this particular one, but I will try and solve the binomial question, the MI question rather, so that we can balance things up. All right, let's solve this one. This one is quite simple. I'm sure you know what to do here. We have to find a constant term. A constant term. When I say find a constant term, this is the mistake some of you do make, is that you want to find a constant term. I'm sure some of you are making this mistake already. So you're probably trying already you want to start expanding all this. Is that if you know you are there and you are trying to expand all this already, can you signify? Can you signify? And you are trying to solve all this. You are trying to expand it already. You started expanding already. I'm sure some of you have started expanding already. Yeah. That's wrong. You're not supposed to do that. Hey, you see them. They are there. Confession time. Yeah, you see them. Yeah. Okay. All right. You don't have to do that. Sincerely, you don't have to do that. You don't have to do that at all. This is what you just have to do. When they told you to find the constant term, the constant term is that term that had x raised to power 0. You know, let's assume you had your binomial expansion, for instance, just for instance, imagine you had the expansion of a particular binomial to be 64 minus 24x squared maybe plus 120x cubed, so on and so forth. Now, when they told you, if they told you to find the constant term here, of course you realize that looking at this expansion, oh, somebody is talking about resuming. Don't worry, I'm going to do lots of videos on all these topics. Like this week now, you'll get lots of topics on trigonometry and binomial expansion. I'm going to be releasing videos on that. So this particular class is going to be for lots of questions. We're going to be solving loads and loads of questions. So, and then you keep seeing videos that will be specific to each of these topics. Just don't worry, I'm going to try my best to help you with that. So now in this case, if you had this expansion, you will all agree with me that this is a constant term. What is the feature of this particular term that made you to decide that this was a constant term? Well, what you could see was that you did not see an x value there. But of course, I told you already in class that it actually has an x value, just, I mean, by default, you just didn't include it. The x value was raised to power 0. So the x value was raised to power 0. So you didn't have, of course, anything raised to power 0 is 1. So it's like writing this. So that's why you had it. So that means one peculiarity of constant values is always that their hex is always raised to the power of 0. Good. We needed that for something. You don't need to expand all this. I won't even expand to find, I won't even find one term, talk less of finding two terms. And I'm going to get my answer. So watch out and let's see. Let's do it together. All right. What do I need to do now? That means I'm looking for a place where my x is raised to the power of 0. Please pay attention. Let me have, like I said, I wanted to expand this. If I wanted to expand this using binomial expansion, I was going to say 8 combination k. Then I'm going to say 2x raised to the power 8 minus k. Then I'm going to say 1 over x raised to the power what? K. This is how I was going to do this. Now, please pay attention. I want to isolate the hex. I want to isolate the x so that I can find something to do that will give me my answer. So let me try and isolate the hex. I'm trying to isolate that. We have 8 combination k. All right, 2 raised to power 8 minus k. Of course, you all understand that. 2 raised to power, and then x raised to power 8 minus k. Then I can write this as x minus 1 raised to power k. All right, good. So I'm sure you can all see now that this particular value here is that's where we can see our constant, our x terms. Now, this is what we're going to do now. Using our law of indices, we want to try and see what will be our k. What should k be? What should k be that would make my x to be raised to the power of 0? That means, what should be my value of k? Yeah, that will make this whole thing to be x raised to the power of 0. We do that using the law of indices. Very simple. Look at it. We are saying we have x raised to the power 8 minus k, and then x raised to the power, we can turn this to minus k, obviously, because minus 1 times k is minus k. We're now trying to ask ourselves that what will this k be that will make this whole thing to turn to x raised to the power 0? I'm sure you can understand what I'm doing here. So we're trying to say, what will be my value of k that will make this turn to x raised to the power 0? Of course, you know your law of indices. You know the law of indices, obviously. At this place, I can decide to say this is x raised to the power 8 minus k plus minus k equals to x raised to the power 0. So following this up, this will be x raised to the power 8 minus 2k equals to x raised to the power 0. I'm sure you guys are flowing because this is quite very simple. So in this case now, you know what to do. I'm sure everybody here knows what to do. You all know indices. You guys are geniuses with indices. I'm sure of that. I'm sure of that. I'm sure of that. So 8 minus 2k equals to 0. 8 equals to 2k, k equals to 4. Wow. Do you see that? That I've been able to recognize now that if I put in k as 4 into this particular place, I'm going to get x raised to the power of 0. That you can go on to attempt that. Put k here as 4. That will be x raised to the power 8 minus 4. That will be 4. And this will be x raised to the power minus 4. Do this using indices. This will be x raised to the power 4 plus minus 4. That will be x raised to the power 4 minus 4. That will be x raised to the power 0. So you can see x being 4 gives me my constant 10. So I don't need to go on expanding. The only reason why I spend this much time is because I'm trying to explain it. If normally you're doing this on your own, you should take like 1 minute to be done with this question. You don't need to expand nothing. You are good without expanding it. So what you have to do now is to use this same thing, fixing your value of k as 4, because of course you know that when you're fixing your value of k as 4, you would get x raised to the power 0, which is going to be your constant term then. So once you have x raised to the power 0, that means the rest will be your constant term. So this will be 8 combination 4, 2 raised to the power 8 minus 4. Then, of course, we don't need to do so much here. All this will turn to 0. So this is what we're going to be solving. What's 8 combination 4, by the way? What's 8 combination 4? Somebody there? Okay. Let me help myself. If nobody was going to help me, 8 combination 4 is what? 70. All right. So 70 times 2 raised to power. Somebody is that will be this 2 raised to power 4 is what? That's 70 times what? 2 times 2 times 2 times 2. 8 times 2 is 16. All right, this gives me 1120. Okay, somebody is feeling like 1 minute is quite too small, too much to solve, or too small to solve this question. Probably less than 1 minute you do it. I actually think you can crack this open in less than 1 minute if you know what you do. So that's it. You can see without having to do any much stress. Get your k value, fix it in, get your answer. This is actually an objective question, by the way. So you're not expected to use 60 seconds on this question. You're supposed to move very quickly. Okay, all right. Now let's do something very quickly. We have this question on MI, and I'm sure you guys are going to PCCs. I trust you guys. You know, you guys are MI geniuses. So let's solve this question on MI. I'm sure you guys are ready. So this will be our last question for the night. We still have questions to solve, but because of time, we have to just end at this point. I would have loved to solve a binomial question, which was a theory question of last year, but probably we'll push that till the next class. So you were told to prove by reason of mathematical induction that 5 raised to power n minus 1, that 5 raised to power n minus 1 is divisible by 4. They say I dey hype you people. I know they hype people. You people are not seeing yourself. Me, I'm seeing something that you guys cannot see. I'm seeing inside your potential. I know you guys have great potential. So don't worry. And we are seeing with the eyes of faith. Okay, so let's do this. So we have to show that 5 raised to power n minus 1 is divisible by 4. Divisible by 4, right? Is there anybody here that can make this happen in 5 minutes time? Just 5 minutes, you can do this. Indicate quickly if you know what to do. To show that 5 raised to power n minus 1 is divisible by 4. Please don't fall my why the chat just stay blank? I'm not seeing nobody raising their hand. What's going on? Come, I've called you guys geniuses, so you won't fall my hand. I'm expecting like make chats they flow. Like you guys should be saying like this is too simple. It's too simple. This is too simple. That's what I'm expecting to see. Okay. Uh, so what do you do? Well, it's very simple. Uh, okay. I love it. I can. I'm seeing I can. Yeah, I can see I can. Yes, you can. Okay, nice. All right, let's do it together so that we can. It's too simple. Thank you, Jerry. Thank you. Elenu. Shena Elenu Abi. Ellen do. Okay, I'll say Ellen. Okay. Okay. All right. This is too simple. Too simple, Abi. All right, let's do it together. Okay, let's do it together. It's actually very simple. You were not going to spend a lot of time doing this because it's very simple. So what's the concept? I'm sure you remember the first thing we're supposed to do. What's the first thing we're supposed to do? We're supposed to first of all do our base step. We must have our base step. Our base step is that we're going to uh, find for when n was, so our base is we'll find for when n was 1. So that's more like we're just trying to confirm that at least for things we can see, it works for things we can see. So let n be equals to 1. So what do we have here? Let's try and see if when n was 1, let's see if it was divisible by 2, it was divisible by 4. So when you fix in n as 1, what do you have? You have 5 raised to power 1 minus 1. This will give you what? 5 minus 1, that's what? 4. Okay, so we got our answer to be 4. So is 4 divisible by 4? Yes. 4 can divide 4. So this works. So we have been able to get for n equals to 1. Let's try for n equals to 2. Just why not? Why can't we do it? Let's just try and do it. Let's see. Maybe 1 was just deceiving us. Maybe let's just try for 2. Yeah, so we must do this base step every time. You need to confirm. If base step no work, then that means you don't need to even go on into inductive step. Do you understand? Why you dey cry say you know this simple? This thing will be very simple. So why raised to power 2 minus 1? What do we have here? We have 25 minus 1. That will be 24. Okay, so the next question to ask yourself is 24 divisible by 4? Yes, it is. So it works. Our base steps are working. So you can go on your own to try for 5 raised to power 3. 5 raised to power 3 will be what? 5 raised to power 3 is 125. 125 minus 1. That's what? 124. Is 124 divisible by 4? Yes, 31 times. So we are sure of our base step now that this works well. All right. Now, the next thing now, we go to our inductive hypothesis. Our inductive hypothesis, where we're going to now assume that when n was k, is going to work also. This is where you need to pay attention. In our inductive hypothesis, okay, we don't need to write that. So assume that n equals to k is true. So what will have to happen for that? Well, how are we going to show that? Please pay attention. If it is true, what's going to happen? Of course, that means 5 raised to power k minus 1 will be equals to what? Let me do something here. I needed to have done something here for you guys to understand much better. This is 4 times 1. That means it was divisible by this thing. This is 4 times 6. You can see that each time when a number is divisible by 4, it was 4 times something, which I'm sure you can all understand. So now, if when n was k is true, that means when we fix in our k value, we're supposed to get 4 times something, 4 times anything. We can put an integer there. So let's just, what letter would you like us to use our integer value as? Do we use m? let's use m. So if n equals to k is true, so that means 5 raised to power k minus 1 must be equals to 4 times a particular integer. We don't know what that integer may be. In this case, now you can see that when it was visible, when we put n equals to 1, we said it was 4 times 1. When we put n equals to 2, it was 4 times 6. So if we put n equals to k, it will be 4 times m. You can put anything you want to. You can put L, you can put Y, you can put anything. But I'm using M. So this is the inductive hypothesis. All right. Now, the next thing and the final step is you will then go on to prove that you will now go on to prove that n equals to k plus 1 will be true. So that's I'm not understanding what Victor Taiwo is saying. Like, do it have to be a number that we can stop at? I don't understand what you mean by what you're saying. So we then need to go on to now show that when n was equals to k plus 1, that is going to be true. But if you're asking of when maybe n equals to 1 equals to 2, how many can you do? You can do any number you want to do. If you use 3 is perfect, 2 is okay, even 1 is okay. So if that's your question. Now, look at something here. We want to prove that when n was equals to k plus 1 is going to be true. So that means we have 5 raised to power k plus 1 minus 1. Of course, when you put in n as k plus 1. So this is what we want to now prove. We want to prove that this this particular thing, when we do it, we will get 4 times an integer value. It could be, let's put p there. We want to prove this. This is what we want to prove. So let's go on with our proving now. I'm sure when you look at this, our inductive hypothesis, you would not blame me if I said my 5 raised to power k was equals to 4m plus 1. I'm sure nobody blames me because you can see that 5 raised to power k minus 1 equals to 4m. We said this was true. Don't forget, we assumed that this was true. That means 5 raised to power k is also the same thing as 4m plus 1. All right. So this is what we want to prove now. We want to prove that our 5 raised to power k plus 1 minus 1 will give me a value that will be 4 times an integer number. Don't get too confused with the use of the word p here. I'm just representing with any integer number. So all I want to, I will be okay if after I'm done solving, I got this thing, this 5 raised to power k plus 1 minus 1 equals to 4 times something. And that something must be an integer. Once it is an integer, then my proof is complete. That's the whole point to all this thing. So let me go on. This is what I want to prove. Let me just go on to pick this out. Let me go on to pick 5 raised to power k plus 1 minus 1. This is what we want to prove. So I'm not wrong if I wrote this as this. 5 raised to power 1 times 5 raised to power k minus 1. I'm not wrong. Because obviously I'm just separating 5 raised to power k plus 1. This is me separating it. So we're just we have separated 5 raised to power k plus 1. This is it. So now I want to go on to fixing my value for 5 raised to power k to be this value here. Because don't forget, 5 raised to power k is this. So I can write 5 raised to power 1 into bracket 4m plus 1 minus 1. Nobody is arguing with me because I know what I'm doing is correct. So I'm not sure none of you is arguing with me. You are not trying to say, am I doing something? I'm doing what is correct. I'm sure you know that. This 5 raised to power 1 is still the same thing as 5. So if I open this, I will have 20m plus 5, then minus 1. Okay? So I can write 20m plus 4. Is anybody here saying that I'm doing something wrong? Is anybody saying that? No, I don't think so. I don't believe that. Nobody can say that. I'm sure you guys know that all I'm doing is mathematically correct. Okay, so this is it now. Look at what I got. Oh. Look at what I got, guys. I got 5 raised to the power k plus 1. Who said it's lost? And where are you lost at? This is what we wanted to prove. 5 raised to k plus 1 minus 1. This is the final step we want to prove. Look at this is the final step. You guys should not be lost. Don't be lost at all. Don't be lost at all. Look at, we have done the inductive hypothesis when we assume that n equals to k is true. So we said if n equals to k is true, then that means 5 raised to the power k minus 1 must be equal to 4 times a particular integer m. That was clear to everybody. So I went on to say 5 raised to the power k is the same thing as 4m. Then I got, so look at what I got 5 raised to the power k as. Good. Now I want to do the final step, which is that I want to prove for n equals to k plus 1 will be true. So I now wrote something here. I said if after I do 5 raised to the power k plus 1 minus 1, if I get a value that is 4 times any integer, I just use it to represent, I just represent it with p here. If I got any integer as my 4, if it's 4 times any integer, then I will say I'm correct. But if I don't get this thing, then I will say it's not correct. So I then went on to look at, and I pulled this here, 5 raised to the power k plus 1 minus 1. So I tried to separate 5 raised to the power k plus 1 as 5 raised to the power k times 5 raised to the power 1. This is what I wrote here, minus 1. That's all I did. So, and wherever I saw 5 raised to the power k now, I'm not wrong if I decided to pull my inductive hypothesis inside there. That means 5 raised to the power k. Wherever I saw 5 raised to the power k, I'm putting 4m plus 1 there. Of course, all these things is still written here. Only that I'm fixing 5 raised to the power k into where in short, I'm putting this into wherever I saw 5 raised to the power k. And then I open this. This is 5 times 4m. That's 20m. 5 times 1. That's 5 minus 1. So this will be 20m plus 4. All right. Good. I love that you guys are saying you understand. That's nice. That's what we're here for. So we can have the perfect and the most perfect understanding of all these things. They are very simple. Don't let all these things be disturbing you. They are quite very, very simple. All right. So look at what we have gotten. We've gotten that our 5 raised to the power k plus 1 minus 1, which was our final step, was equals to 20m plus 4. Now let's do something now. Let's decide to factorize 4 out. What are we left with? We're left with 5m plus 1. We factorize 4 out. Now let's now pay attention to something. Can anybody here tell me, with this value here, this 5m plus 1, is it going to be an integer or not? I want you to investigate it with your own mind. 5m plus 1, is it going to be an integer? Is it going to be an integer value or not? Of course, let me answer that in case you are still wondering. It's going to be an integer, and this is why. Don't forget, this m we are dealing with here, this m, we told you that m here was an integer. Because we said if n equals to k is true, then we said 5 raised to the power k minus 1 must be equal to 4 times a particular integer. So if it's 4 times a particular integer, that means m was an integer. You know what integers are. If this is an integer now, if you multiply an integer with 5 and add 1 to it, pick any integer, multiply with 5 and add 1 to it, your value will still be an integer. Let's take, for instance, an integer of 10. 10 times 5, 50. 50 plus 1, 51. That's an integer. Do it for any value of an integer. You will always get an integer back here. So that means I've been able to prove now that my 5 raised to the power k plus 1 minus 1 is equals to 4 times a particular integer. We can call that integer p, as we did here. So that means it's equal to 4p. We can call this p. So you can see from here that I've been able to prove now that my 5 raised to the power k plus 1 minus 1 is actually divisible by 4. Because if it's equals to 4 times an integer, that means that's divisible by 4. Does it make sense? Does it make sense? This is quite simple. I want you guys to understand MI very well, because these are questions that they can likely bring out, and I want you guys to be very solid. All you need to do is to know what you're doing, know your stuffs, and you can't go wrong. So let me get your feedback now. Let me get your feedback. How do you feel? How do you feel about everything we've done today? Were you able to comprehend it? How do you feel? I'm waiting for feedbacks. 37 likes. You guys are here and you're not giving thumbs up to this video. Can you imagine? This P is just a dummy for an integer. Please don't. I just want you don't get this stuffed up in your head. This P is just me saying, let's just represent that this thing is, M can be anything. N can be 10, N can be 11, N can be anything. So we just want to represent whatever is here with P. So you can decide to abuse the Y. That okay, my integer value, my resultant integer value when I do 5 times an integer plus 1, whatever I get, let me call the integer value P. Let me call it Y. Let me call it Z. So whatever you want to call it is up to you. So I'm just using P there. It doesn't. This P is the same thing. I'm using it just for the sake of indicating that an integer value is what we are dealing with there. That's just it. All right. Okay. It looks like the likes the thumbs up has increased. Okay. Okay, for 50. So you guys were sleeping before. Okay. Oh yeah, okay. Somebody said with more video you have a perfect understand. Yeah, I aim to give you more videos on this. I've not done any particular video on MI, but I will. By God's grace, I've focused more on trigonometry and then I've done a little bit of binomial expansion. So so we'll be releasing more videos. So don't forget the aim. You guys should not forget the goal. The goal is at least 50% must get A this year. And I'm sure you are one of them. I'm sure you guys are one of them. So it was great this night. Of course, it will get better because my commitment is to seeing that you guys are going to do you guys are going to do great this year. I'm seeing you guys comment and you guys are just quite hilarious. So okay. So I don't even know many people many people by their name here, but I'm sure you guys have a face in the class. Okay, so you'll be seeing videos on trigonometry from tomorrow. A complete guide on how you're supposed to understand a complete guide on it. It's quite perfect. Very, 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 very great. From tomorrow, you start seeing videos on that. Yeah, we're going to do more videos. We're going to do videos on other aspects. Don't worry. We're going to drop more videos tomorrow. From tomorrow, it's be coming in the morning around 6 a.m. to 6:30 a.m. and then in the evening around 6 a.m. to 6:30 p.m. So 6 a.m. to 6:30 a.m. expect videos, and 6 p.m. to 6:30 p.m. expect videos. Around that time, we'll schedule videos for those moments. So we'll solve more questions. There are many questions. We're just still on about a year. This is just last year we have been moving on. But one thing I'm joyful about is that you guys will get more confident in solving any sort of questions. Like there's no way they want to bring out questions from. You guys are going to be ready. Like you're going to be really, really ready. So those of you that are quietly there, of course, I'm saying hi to you. I know you are not probably chatting, but okay, somebody's talking about buying data. Exactly, exactly. And marker. Eh? Okay, that's nice. You guys are enjoying yourself. Please burn the midnight or do whatever you have to do to achieve this success. It's very possible. Very, very possible. It's very, very possible. So this is nice. I think we have come to a good moment of the night. Yeah, I love that. We'll dissolve JUPEB. We'll dissolve it. You scatter it. You pieces it. There's no way they want to bring questions from. We're going to have A. It's going to be A. It's going to be A. A is going to be like it's going to be like as if it's the easiest thing in the world to get. So you guys are doing well. So I wish you guys all the best. We'll see you tomorrow by God's grace, and sleep well. Of course, sleep well, but don't sleep too much. Wake up in the morning and get yourself get yourself ready for the day. All right. So we're going to end the stream at this point. I wish you guys all the best. Enjoy. Okay, yeah, that's true. Happy New Month in advance. Okay, tomorrow is Happy New Month. Happy December. Yeah, it's that time of the year again. All right. Good night. You guys are so funny. All right. So enjoy yourself.